All right. So again, back to it. Again, where was I? All right, I got this formula here. We are finding, it's a good thing I write down my givens and stuff. I know what I'm looking for. Delta X. All right, so I'm going to substitute in. So what do we got here? V1X is 40. Our delta T was 7 seconds. All right. Okay, and now I substitute. Let me see, I got a half. Oh, that's again 0.5. My AX is 0, and my delta T again is 7 squared. All right, now delta X. Let's see. Now, see this term? We have 1/2, or half, 0.5, times 0, times 7 squared. Well, when you times anything by 0, it's going to be 0. So all of this is going to just be a 0. And so our delta X is going to be 40 times 7, which if I put that in my calculator, 40 times 7, we got, 280 meters. So this thing lands 280 meters away. Almost 3 football fields. Well, actually, meters probably is a football field. So there we go. We got our 280 meters where it lands. All right, so I'm going to put that information in there. And that's A. Woo. All right, now we get to B. We get to B here. So I'm going to erase this again. Going to leave my information here. All right, so it says, what is the final velocity of our cannonball? Now, we had this type of question before. And the thing is that before it was easy because it was level ground. So where the ball took off, it landed at the same velocity, only your velocity was directed downwards instead of upwards. But here we're not on level ground. This cannon is being shot from a 100-foot cliff. So when it lands right here, this is kind of an up-close look at it. There's our VF. Now, our VF consists of, again, 2 components. We have the, let's see, I'll get my colors right here. We have our vertical component of it, which is clearly directed down, which would be our VFY. And we also have our horizontal component, which would be our VFX. Now, if we know those 2 components, we've done this before, where we can put them together and come up with a final velocity. Well, I do know this one here, VFX, is 40. So that helps. But VFY, unfortunately, I do not know. But if I do find it, then I can put those together using trigonometry and the Pythagorean theorem to find my final velocity. So I got to find this VFY first. All right, so again, over to my motion equation sheet. All right, I need my VFY. So I'm dealing with all this information right here. I'm down to the verticals. So I need a VFY. Okay, so I go to my first equation. I got VFYs in the equation. I need an A, which I got. I need a V1, I got it, and I got a delta T. All right, so I can use the first equation. So I'm going to do that down here. So I got A is equal to VF, well, I should call it AY, sorry, VFY minus V1Y divided by delta T. All right, so again, my AY is negative 9.8. VFY, that's what we're trying to find out here, minus V1Y, which is our 20. And it took 7 seconds. All right, so let's see here. I got a number equaling a fraction. So again, I like to go a fraction equaling a fraction here. And so I'm going to have 1 times this whole thing. So that's going to be that whole thing. And then I have 7 times negative 9.8. Now I'm going to need a calculator for that. And let's see here. 7, whoops, clear. 7 times negative 9.8. And I get negative 68.6. All right, I'm going to bring that negative 20 over to the other side. And so again, when it changes sides, it changes sign. So it's going to be a positive 20. And so I get my VFY to be, let's see here, negative 48.6. So I'm going to plug that in here, negative 48.6. It's negative because the cannonball's on its way down vertically. So that's why our final vertical velocity is negative. So that's up here. The magnitude of it, that's all I'm worried about here, 48.6. All right, now that I have the vertical component and the horizontal component of my final velocity, I'm going to put them together again using the Pythagorean theorem and trigonometry and figure out what the VF is. So again, I've got VF squared is equal to 48.6 squared plus 40 squared, again, using the Pythagorean theorem. Now, if I use the Pythagorean theorem, let's see here, I end up with, let's see, skip a few steps here using the old Pythagorean theorem, I get 62.94. So there's the magnitude of my vector. Now the angle, what angle am I looking for? Right, this is a right angle here, so that's not going to be the one. So I'm either looking up here or down here. Well, again, this blue line refers to the ground. The green line doesn't really refer to anything physical. And so I'm going to find theta. And so again, I'm going to use my trig where I've got tan theta because I have the opposite and I have the adjacent. So tan theta equals 48.6 all over 40. All right, so I can find that angle. So let me see here. I take my trusty little calculator here. I get 48 divided by 6. Or sorry, 48.6 divided by 40. All right, then I go tan inverse. And I got my angle to be 50.54 degrees. And so now I can write down my VF. The final velocity, I'm going to put a little arrow on it, is that the magnitude is 62.94 degrees. And that, whoops, forgot my units, can't do that, meters per second. And my angle here is 50.54 degrees with the ground, or sometimes you'll see horizontal. And there is, well, not degrees, that's meters per second there. There we go. And so that is our final velocity. Again, it's not the same as our initial one because the levels are changing. Where that did not happen in our first example, the soccer ball was kicked from level ground and it landed on level ground, which naturally is pretty good for a soccer. You wouldn't want soccer hills in a soccer field. Although I've seen some high school soccer fields that don't look that great. All right, so